In this video, we will discuss the algebra of complex numbers with a focus on the trigonometric form, also called the polar form. We'll see how to add and multiply complex numbers using angles and magnitudes. Let's start with the complex plane. The horizontal axis is the real part, and the vertical axis is the imaginary part. We'll place a complex number z with magnitude, r, and angle theta measured from the positive real axis. In trigonometric form, we write z equals r times the quantity cosine theta plus I sine theta. This highlights the magnitude, r, and the angle theta. For addition, we still add real parts and imaginary parts. But visually, we can see it as adding vectors. Let's add another number w and draw the vector sum. Now, the trigonometric form becomes powerful for multiplication. If we have z1 equals r1 times cosine theta 1 plus I sine theta 1, and z2 equals r2 times cosine theta 2 plus I sine theta 2, then their product has magnitude r1, r2, and angle theta 1 plus theta 2. Let's visualize multiplication as a rotation and a scaling. We'll rotate z by adding a new angle and scale it by stretching its length. Finally, de Moivre's theorem tells us how to raise a complex number to a power. If z equals r times cosine theta plus I sine theta, then z to the n equals r to the n times cosine n theta plus I sine n theta. This means powers multiply the angle and raise the magnitude. So the key idea is this. In trigonometric form, multiplication adds angles and multiplies magnitudes, and powers multiply the angle and raise the magnitude. That's the algebra of complex numbers in trigonometric form.